Welcome back. After hooking the NDK functions the easy way, now let's have a look into the hard way. Exactly this one over here. So we have to deal with tons of stuff if we want to hook a native function. And to be honest, we do not get any advantage out of this one right now. Nevertheless, we are doing this. Why? Because we will later on deal with a function where all this knowledge right now will come super handy. Alrighty? Okay, so please see this as some kind of practicing for a challenge we are doing later on. And therefore, let's figure out how we can hook a function not in the Java world, within the C++ world. Let's go. Alright, so here we're having our C++ code. And the first thing we need to do is we need to identify the function we want to hook. I mean, we could have reverse engineered this application, but by doing this, we would miss a lot of things. And for example, we do not get things like the function pointer or other stuff. And therefore, we are using Frida, because Frida has also the ability to enumerate all these functions. Frida can not only enumerate them, Frida is also providing the function pointers for them. So we get all the addresses of these functions over here. And let's say we are interested in the following, in this one over here. Then we can simply list all these addresses, and then we can select the address that's related to this one, to this function we want to hook. This one over here. Having the address, that's all we need. So we can now use our interceptor.attach to attach to this address. And this means we are observing everything that happens over here. And here we are providing now our two callbacks, our onEnter and also our onLeave callback. The onEnter callback will be called when we are entering this function. Within the onEnter, we are having access to the parameters. The onLeave callback will be called just right before we are returning out of this one. This means we are still having access to the return value. So this is directly before we leaving this function over here, and therefore we can still observe the return value, and we can also apply a patch on this one. So we could modify this one over here. Alright. In total, it would look like the following over here. So this is the summary of our interceptor.attach. We attach to this function pointer, and every time we are entering this function, we can apply our patches. And every time we are leaving this function, we can also apply our patches. Alrighty? Okay. The only question that's left is the following. How do we get these functions and all these addresses? And Frida has a lot of amazing capabilities to do this. So my three favorites are the following. Module, dot, and then we can enumerate imports, exports, and symbols. We will have a look into each of them, and we will also figure out what's the difference between them on the graphic tablet later on. For now, I would suggest let's simply start over here. So we will make our way into this topic step by step. Alrighty? Okay, let's go. Let's switch to the Ubuntu VM and let's see how we can hook a native function with Frida. Let's go. Alright, so here we are back at Ubuntu VM, and now let's have first a look into this application once again. So we get back the smartphone screen, and here we can see this is our app. If we hit the crypt button, then we can see it's crypting this text over here. And let's change this. Frida is awesome. Let's see. Yes, it's still working. All right. Now let's open this application with JDX GUI and let's figure out the function name we want to hook. Alrighty? Okay. So we close this one. Then we open a new terminal and we go into apps, NDK Frida. Oh, here I named it differently. Frida NDK. There we have it. And now let's open this one. Okay, we go into the Android manifest and we click into the main activity. Alrighty, let's see. There we have it. This one over here, yes, decrypt string. So this is the method. So this is the method we want to hook right now. Therefore, let's fire up Frida and yeah, let's have a look on how to enumerate this method with Frida. So we open a new terminal, we are connecting to our device, root privileges, and then we start up the Frida server. Alrighty, Frida is running. Put this on the right, this one in front. Close this one and we put this on the left. Okay, now we attach just simply to this process. So Frida-u and then com app hacking, and this one is NDK Frida. Now we are connected. So the first thing we need to do is we need to identify the address of this function over here, decrypt string. And we can do this in the following way. So Frida has this nice module feature. And if you click or enter module dot, then we get all these methods that are available. We've got one that is enumerate exports, imports, and I guess symbols. Enumerate symbols. All right. Now's the question, where's the difference between all of them? So what are imports, what are exports, and what are symbols? Let's find this out right now. We start with exports. Okay, if we simply hit enter, then we can see this one is in function. So we have to provide a function to this one. So we need our brackets. If we do it this way, then we can see it's expecting a string. So over here, we need to tell Frida in which library it needs to look for all these exports. And this library can be found, let's see, over here. Within lib, we have this libnative-libso. So this is the library where we want to enumerate all these exports, because this is the library that's being loaded over here as native lib. And this is the library that contains our method. Alrighty? Okay. So let's see, enumerate exports, and we have to enter, this on the right, we have to get this name. libnative-lib.so. Okay, if we now click enter, then we can see, alrighty, we are getting back an array, and this array has 3 entries for every function: the address, the name, and the type. Okay, so over here we can see it's not just related to functions, it's also related to variables. And sorry for this wording, this is regarding to all exports, not just functions, also variables. Alrighty. And let's see what we've got inside here. So these are the exports, and this list is huge, I guess. Yes, we've got a lot of stuff in here. But if we scroll upwards, okay, that's not, let's see. There we have it. So let's go down a little bit. Okay, so here we are at the beginning, and now let's go down a little bit. All right, and here we already have it. Java.com app hacking NDK Frida main activity decrypt string. This is exactly the function we want to hook. Amazing. So this one over here, that's the address. Absolutely nice. We are now having the address of this function. We are now in, let's see, enumerate exports. So where's the difference between exports and imports? Let's do this for the imports, and maybe then it becomes a little bit more clear. Enumerate imports. Yes, and so here we can see vprintf, free memset, memcopy, malloc, vas printf, memmove, string compare, and things like this. So let's take a quick look on the graphic tablet and figure out what are imports, exports, and symbols of this file over here, of this native library. Alrighty? Okay, let's do this real quick. Okay, so here we're having our library, and this one has been written in C or in C++. Now let's assume we've got the following code line. We've got an printf, and we're printing out hello Frida. At the moment right now, this function over here is unknown to the program, and therefore it will be flagged as red. Alright, if you want to use this out of the standard libc, then we have to do the following. We have to include the standard io.h file. So this standard IO header file will be included into our program over here in this one. And now the program knows, okay, this one, that's the printf function out of the standard IO header file. Now I know this, and this function won't be flagged red anymore. And so this means we're having here now our standard lib library. This is our standard libc, and this one is now defining all these functions. And for example, printf, fopen, and more. So all these functions are being defined in this library, and they can be now imported into our program. And this means all these functions over here, these are imports for our program right now. So we are importing these functions into our program via this one over here. Alrighty? Okay. Imports therefore simply means functions that are coming from a different library. Alright. Then let's say we've got this one over here. So we've got our decrypt string. And this one needs to be available outside of this library. For example, in our Java code. Therefore, we need to export this function to make it available in another program. So this one is now outside. So exporting simply means taking a function that has been defined by us. So this has been defined by us and make it available to the outside. So if someone is including this file over here, so this will be included, then this function is also available for this program right now. All right. Okay. So this would be an export. This one over here. Okay, last but not least, we've got symbols, and symbols are just functions or variables that has been defined in our program. And so functions or variables in our program that has not been exported to others or imported from others. So this is just, for example, something like this. String pw equals secret. All right, and this one over here, pw, this would be in symbol. By having those three right now, we can access everything we want. For example, if you're looking for something that has been imported from another library, then we can check the imports. If you're looking for something that we are exporting to other libraries, then we can check the exports. And if you're looking for something that has been defined in our code, this one for example, then we can look for symbols. All right. So now, all right. Okay. Okay. So this one over here, this is the difference between imports, functions into our program, exports, a function out of our program, and symbols, stuff only available in our program over here. Okay, so now we understand them, and this will help a lot in identifying what we are looking for. And therefore, let's switch back to Frida. Okay, so here we are back at the Ubuntu VM. And now let's have a look into this one once again. We've got memset, memcopy, malloc. Do you still remember if these are now exports or imports? Of course you do. These are imports, and you might have already seen this over here. These are being imported from the libc.so. Alrighty. So if you're looking for methods like string copy, string compare, memcopy, memcompare, and things like this, we have to look into the imports. Okay? Perfect. Now let's dive back into the exports. So let's change this one over here. Okay, and here we can see these are now all our exports in our library, in our native libso. If we go back to the top over here, so then we can see these are a lot, and it's absolutely ridiculous to find our method in there. So if we scroll down, then we might identify it over here. And here we are also having this address, this piece what we are looking for, but to be honest, this is not a good approach. I do not want to search manually through all of this. And therefore, let's create a new file within our Visual Studio Code editor, and then let's figure out how we can do this automatically. Every time we are starting this application, let's fetch this address. Alrighty, let's do this. So we open up Visual Studio Code. Okay, there we have it. This time we do not have our java.perform approach because we're not in the Java world anymore. We have already figured out the command we want to use. This one over here. Maybe let's put this on the right and this one on the left. Okay, I hit the upper arrow key, then I get the last command, this one over here. This will return an array with all these values, address, name, and type. Let's copy this one and paste it in here. Okay, now let's create a new array. But before we do this, we switch back to JavaScript. Okay, now we are creating a new array and we name this exported. It's a little bit laggy on my side. I guess I close the screen copy. Okay, exported functions. Yes. If we are executing this one over here, then we have now this exported functions, and this one is an array that contains all the stuff. We can use this to access one field, for example, this way. And then we can say, for example, address. This is now the address of the first element. We can also print out the name. And by doing this, we can now look for our function. So the function we are looking for is decrypt string. Therefore, we write an for each loop on our array. Maybe let's comment this real quick. Getting all exports out of the libnative-libso. Iterating over this array, trying to find decrypt string. So we can iterate over this one. Let me put this on the right via the for each loop. Yes, this one is an array, therefore we have this function. Okay. So we've got two parameters, an element and an index. I'm not sure if we are using this index right now, but it's good to have. Okay, now we can simply use our if statement. So if element.name, and in JavaScript it's not contains, it is, I guess, includes. Yes, okay, if this keyword is included, so the keyword which we are looking for is decrypt string. Then let's see, we want to print it out. And we want to print out the element.name. Let's copy this. The element.address. Okay, and let's try if this one works. Perfect. We've got this within send, which is not that nice. We can also replace this with console log. Okay, and let's do this once again. There we have it. And this is our name and this is the address. Yes, the address should be right. Okay, nice. So now we can also create a new address. Let's call this decrypt string address. Okay. Address of the function we want to hook. Now let's make this a little bit nicer. So this is the name. And here we're having the pointer. And now we are also filling this array, this variable over here. So this one is now element.address. Yeah, without a bracket. Okay. This should work. Let's do this one more time. Alrighty, this means decrypt string address. Here we have now our address. Perfect. We can now use this within our interceptor.attach. So this is the last blueprint, the third part of our Frida syntax we need to memorize. And to be honest, it's pretty identical to java.choose. So instead of java.choose, we're having interceptor.attach. And here we're having now our address, which is this one over here. And then we've got a comma and we've got our callbacks. All right, these callbacks, double click, curly bracket and enter. Exactly like we have done this in java.choose. Alrighty, now let's define them. We've got our on enter callback. We are providing an anonymous function. And this time we are only having one argument, and this is an array of arguments. So this will be done automatically. If you're having 2 elements, then we've got arg0, arg1. If we are having 5, then we've got arg0 till arg4. Okay? All right. So let's print this out. Send. We are in, there we go. Decrypt string address. Okay. Then we've got our onLeave callback. Same approach. And this one has also this time in parameter, which is the return value. I name this normally red. And we also printing out, we are leaving the decrypt string function right now. Sorry for this one, that's a bit confusing. Decrypt string. Let's see if this is the correct name. Yes, okay. All right, and this is how we can enter and leave a function, or hooking the entering and leaving a function. And let's combine this all together right now. So I clear the screen and I apply it once again. All right, and now let's get back our screen. Let's trigger this function and see what happens. I hit crypt in 3, 2, 1. There we have it. We are in decrypt string, we are leaving decrypt string right now. Perfect. So we can see this one works out. I mean, it doesn't look that complicated anymore, right? Regarding to this one, I mean, yeah, okay, we have to memorize some new stuff. But regarding to the approach, it's pretty identical. Unfortunately, not. And this is not even close being identical. So we have seen this hilarious typecasting in our C++ code, and if you now want to access these parameters, this will be messy. Let's try to access them. So for example, we want to print out, maybe let's do this underneath. So over here, yes, I have to close it, it's still laggy, and there we go. Okay, we do not want to send this. So we want to print out the first parameter. And then this one should be args0. Okay, and then we also want to print out the second parameter. And this one here is the second parameter. So these are our 2 parameters. Let's put this a little bit more left. And password and 4. So these should be printed out right now, right? Let's see. Let's copy this. And let's get back to our Frida script. Maybe let's keep this in foreground. Okay, let's also pull out our screen over here. So here we have our screen. And now let's see. I'm inserting this and I hit crypt in 3, 2, 1. All right, it seems to work, but these are looking a little bit strange. So this looks like addresses, right? And yes, I guess these are addresses. So it seems like I have forgot something. Let's turn back to the slides and let's figure out what I did wrong over here. Okay, so here we are back on the slides, and yes, we've got 4 parameters. So the first 2 are regarding to our chain I environment pointer. The second one is this object. The third one is this parameter 1, and the fourth one is parameter 2. All right, so absolutely my fault. We have to hook arg2 and arg3. So counting from 0, and this one here is arg0, arg1, arg2, and arg3. All right, let's simply fix this over here. So back to this one. This one is arg2, and this one over here is arg3. And let's do this once again. Okay, sorry. And let's get it over here. So I hit crypt in 2, 1, let's go. Ooh, something is interesting. We still got first, second. So beside forgetting about renaming this, we've got it now twice. And this is something I encounter a lot. So overriding a method regarding to interceptor.attach is not a good idea. We will override it, and on the second attempt we will override the first override, and then we have this mess over here. Therefore, let's simply close this application and restart it. I mean, we can also save this and yeah, provide a tune file. But yeah, for now, let's do it in the command line. I guess that's a little bit easier. Okay, so now we are restarting this application. And I guess this one is not longer required, this JDX GUI. Therefore, let me switch this real quick because my Java seems to lag a lot right now. Okay, so here we're getting back our screen. Okay, so let's try this over here. So I hit crypt in 2, 1. There we go. And the first parameter is, what is this? The second parameter is 4. Finally, we have one value in there. So this is our value 4. All right. This is amazing. But this one is ridiculous. So what is this one over here? Okay, so over here it seems like we are having an address once again. This might be in string, but it might be in different type of string. So we cannot simply print it out in this way. We could try something like, let's see, in JSON, stringify. Let's see if this works. Okay, so I hit exit. We run this once again. I'm providing it. And here we have it. Okay, let's see. Yes, even JSON stringify is not being able to get the real string out of this address. So the only approach right now I know is converting this into a real Java string. And this can be done with java.cast. So if you're taking a look into the Frida documentation, so this one over here within docs, we've got the JavaScript API, and here we have something java.cast. Where do we have it? Here. And create a JavaScript wrapper given the existing instance at handle of given class as returned from Java use. So first we need to use java.use over here. Yes, perfect. We can see this over here. We are using the java.use for the string class, and then we are typecasting this address to this string. And afterwards we are being able to print the string. All right. Okay, I guess now you know why this one is being called the hard way. All right, let's do this. So let's see what's the Java string class. And therefore, I'm searching for Android developer Java string, and here we have the developer-android.com, the documentation, and we can see a string is from the class Java lang string. All right, and let's do this right now. So this one over here, let's see, this one. This needs now to be typecasted. So we need to do it in the following way. First, we need to get the class reference of a string. String class ref. We can do this with java.use. And let's put this on the right. So here we're having, there we have it, in Java lang string. Okay. So now we're having this reference. Oh, this needs to be within the onEnter method. Okay. And now we can create a new instance, a string instance, and we can typecast it right now in the following way. I mean, we can have a look into the documentation, and it's exactly this one over here. So we can use java.cast. Then we provide this pointer, which makes sure that this one, which we are providing over here, is a pointer. So we are providing this args3, and we want to typecast it right now to our class reference, a string class reference. All right, now we are having finally a string that can be printed out, hopefully. Let's see. Okay, and therefore let's go back into this one, close this one, we insert it. Okay, and now we are using screen copy. Let's see if this one here works right now. So I hit encrypt in 3, 2, 1. Okay, it did crash. That's unfortunate. Let's see. There's a problem regarding to this pointer. And here we can see decrypt string chain I error detected, use of invalid object 04. Okay, let me check this out. What did I do wrong? Yes, I'm absolutely sorry for this one. This one it's not our integer. This is our string value. So we have to change it from 3 to 2. And let's see. Yeah, this one is our first parameter. Yeah, so I'm not sure what I was thinking about right now. Okay. But it's good to see that, yeah, those Frida typecast handling works properly. All right. So this is our string argument, arg2. The first one is chain E environment pointer. Then we are having this object. Then we are having our password, which is this one. And then we have our integer parameter. All right. Let's try this once again. Oh, sorry, not here. Over here. The process has completely died. Okay, so we have to restart it. We are using Frida to restart it. Okay, here we have it. And yes, we are attached. So now I'm pasting it in. And now let's see if this works out. So 3, 2, 1. There we have it. Udemy app hacking. This is our string that we are providing to this function. Yes. So now we can see we are having a string and our integer value. I mean, it's in hex, but this is fine for us right now. We could also typecast this to an integer value, or we could also use functions like toInt32, I guess. Let me check this out if it wasn't this way. toInt, yes, toInt32. Maybe let's do this real quick. I guess this is how we can convert this into an integer value. Okay, so we start it once again. And then let's see. Yes, all right. So now we have it also here. This is our integer value, okay? You can see this documentation over here, that's a treasure. There's a lot of stuff in here. And yeah, I really highly recommend reading about this. I mean, there's a lot of stuff and most of them is really complex. I'm absolutely honest with you at this point. But sometimes you can also have some quick shots like this one, for example. Typecasting a native pointer to an integer. All right. Now I did know that this one is named toInteger, but at least we could find this in the documentation. Alrighty? Okay. So now we can also try printing out the return value over here, this one. And let's see, this time, let's do it this way. Let's first print it out and see what it is. Okay, and then we try to print it out. Or maybe not. Let's see. Application restarted. We are entering this. We are hitting crypt. And we can see the return value is hex 71. This is not even, it doesn't look like a pointer anymore, right? And yeah, printing out the return value is a topic on itself, which we will cover in the next video. For now, we stick to this one, okay? So we have seen how complex this is, printing out those values. Regarding to a string, most of the time, I guess barely all the time, we have to typecast it. But we can see how we can do this in the following way. Printing out integer values. Okay, this one works on a hex base. But yeah, we can also use this function toInteger32 to print this out. Okay, for now, this is all for this video. In case of any questions, as always, feel free to write me a message. And otherwise, I'm looking forward to see you in the next video. See you there.